Live from the Space Coast of Florida, this is NASA's launch coverage of NOAA's GOES-T mission. In just about 40 minutes, this United Launch Alliance Atlas V rocket will launch GOES-T into space. The satellite will continue nearly 50 years of protecting people and property from severe and potentially deadly storms. Welcome and thank you for joining us here at Kennedy Space Center in Florida. I'm NASA's Megan Cruz. The rocket's right there on the pad behind me. And this is Kevin Fryer. He's with NOAA, the National Oceanic and Atmospheric Administration. Great to have you here, Kevin.
Great to be here, and thank you for having me.
It's kind of cold, though. A little windy.
A little windy, absolutely.
I think that's going to be the biggest concern for the launch today, but so far we are 80% go, so I hope that we can see this thing launch today.
Yep, that's great news.
Kevin is here because GOES-T is a NOAA mission. NASA and NOAA have been launching GOES satellites since 1975, right?
Yeah, it's an amazing relationship that we've been able to have with NASA. Over the past 50 years, the one thing that we can say is that we've actually saved lives as a result of that. We've also obviously moved the science forward with advanced satellites, but for the most part, what we like to hang our hat on is that we've saved lives.
Yeah. GOES-T is the third in a series called GOES-R. You know, you're the chief of staff of that program. Can you tell us a little bit about that series?
Sure. Within the program, we like to say that not only can we provide you with a big picture, but we can also read the fine print. Again, being one of the most sophisticated satellites in the geostationary orbit, our capabilities are basically to provide you with a constant view of the Earth. In our case, we're able to look at half of the globe, and in doing so, we're also able to inform you on the environmental changes over time.
So GOES-T is going to be looking at what happens here on Earth in terms of terrestrial weather, but also space weather?
Right. That's another reason why we're incredibly excited about this package that we'll be able to launch today. Not only are we improving what we can see on Earth, but also what affects us from space.
And space weather does really affect us. I learned that while I was researching this mission, so I'm interested to hear more about that, and we will learn more about it later in this broadcast. Plus, how you benefit from GOES data every single day. Also, if you have a flight to catch, GOES satellites play a crucial role in deciding if it's safe to fly. And we also have a fun game for you to play while you watch the broadcast and the launch. This here is a bingo card that you can print out by just scanning this QR code you see on the bottom right-hand corner of your screen. We also have the website there if that's easier. That's scijinx.gov/GOES-T-launch. NOAA has a list of words that we've incorporated into this show, so be sure to listen for those words and see which family member or friend wins. But first, let's meet the talented team of people helping to cover today's launch. We have meteorologist Arlena Moses monitoring the launch weather. NASA's Leah Martin will introduce us to key players in the GOES-T mission. And we also have our NASA launch commentators, Daryl Nail and Mick Woltman, inside with the launch team there. You know, Mick is an engineer with NASA's Launch Services Program, which is managing today's launch. So, guys, the 2-hour launch window opens at 4:38 p.m. Eastern Time. How are we looking?
We're looking great so far, Megan, and thank you. Welcome into the Atlas Spaceflight Operations Center here at the Cape Canaveral Space Force Station. Mick Woltman, as you mentioned, LSP engineer extraordinaire and
Appreciate
rocket
that,
guru.
Appreciate that, Daryl.
So far, it's good to have you back into the broadcast booth for another launch, and so far, so good.
So far, so good. We just entered the T-4 in holding. This is a 30-minute built-in hold where the team is going to, look at the vehicle and finalize last-minute preparations as we head down to T0 this morning. So the team's done a great job, been on console for several hours, and has gotten this rocket ready to go. So looking forward to this.
That shot from the ground there, looking up at the rocket, you can see the skies are blue. We've got some clearing throughout the day. Started off windy and a little overcast, but there you see the clouds moving across the pad. Very light, very scattered. Now we want to tell you where we are. We are in the nerve center of where launch is happening. We're going to turn around in our seats and wave at the camera. We're up here on this second level, but down below on the first level is the launch team. team, and you can see the 3 levels there, the 3 rows. This is where all the action is happening.
Yeah, this is the United Launch Alliance team. This is their Launch Control Center. And Daryl, as you said, this back row that's closest to us, this is where the launch conductor, Dylan Rice, is sitting, along with his assistant launch manager, the anomaly chief, Dave McFarland, and our red line monitors, who are monitoring all the telemetry and everything on the vehicle and on the ground. In the middle row, you have the team that is working both the first stage booster and the second stage Centaur propulsion teams there. And in the front row, you have flight control and electrical systems that are monitoring the guidance, nav, avionics, and all the electrical systems on the rocket. So as you can see, a lot of team members from United Launch Alliance to work this Atlas V.
And they've been quite busy for the past few hours, making sure that the fueling operation has gone smoothly. And they were also on console yesterday, Mick, when we rolled this rocket from the vertical integration facility to the pad. We got a little video there, and you can see there it is, the Atlas V coming out, all 200 feet tall rocket coming out of the vertical integration facility and rolling about 1/3 of a mile out to the launch pad. Mick, you were out there. Pretty smooth operation.
Yeah, it was. The team did a great job making that trip about 1,800 feet to the pad, traveling about 1/2 mile an hour on the mobile launch platform and everything there. And team did great getting that out there and ready for RP1 tanking and then launch today.
You look at the rocket there, and it carries a special dedication today. Mick, it holds the name of a former ULA employee by the name of Mark Tim. Mark started his long aerospace career with the Boeing team in 1987, but after a decade in Denver, Colorado, he transferred to ULA's facility in Decatur, Alabama. That's where Mark Tim supported the ULA's fleet of rockets, including the Delta II, Delta IV, Atlas V, and Vulcan. There you see him in the middle, surrounded by NASA astronauts. Mark Tim passed away in 2020, and he's missed by all those who had the pleasure of working with him during his 30-year career in aerospace. And Mick, you knew him.
Yeah, I got to know Mark when he was in the Decatur facility, and I'll tell you, he was an extraordinary person. The team will miss him, and our heart goes out to the family and everyone that worked with Mark. He was a great guy.
And just wrapping up, we are on time and on schedule for a 4:38 p.m. Eastern Time launch of this Atlas V rocket. A beautiful shot from a drone there. We are ready to roll. We'll have the LSP NASA Launch Manager poll here in just a few minutes, but for now, back to Megan.
Thank you both. And now for a check on the weather, here's Launch Weather Officer Arlena Moses from Cape Canaveral Space Force Station's 45th Weather Squadron. Arlena, this launch weather you're about to report out, forecasted with data from GOES satellites, right?
Yes, that's correct, Megan. In fact, right behind me is a great example of the type of imagery that we get from the GOES satellites. In this case, because we're here in Florida, this is from the GOES East satellite, giving us a great view of what's going on across the Cape and East Central Florida this afternoon. Now, as mentioned earlier, we did have quite a bit of overcast clouds and some low clouds out there earlier today, but as our satellite imagery is showing, we've scattered out pretty nicely with only a few clouds as a concern as we go to the remainder of the launch countdown. The trade-off, however, for those clearer skies and partly sunny conditions is that we do have pretty breezy conditions out there. Sure, anybody who's outside across the Cape this afternoon is experiencing. And those are going to be our primary concerns as we go forth into the count for the remainder into the launch. Now, if we take a look at the forecast here, we're going to be looking at those pretty gusty northerly winds from about 26 to 32 mile per hour range. Temperatures about on point for this time of year here in Central Florida, where temperatures are going to be in the upper 60s to around 70, which will feel a little bit cool if you're outside with that, but for launch concerns, not a big deal. As I mentioned earlier, liftoff winds are going to be our primary concern, with a smaller concern for some of those passing cumulus clouds. But overall, we have an 80% go for weather, and things are looking good. And so hopefully good launch. Keep our fingers crossed. Back to you guys, Megan and Kevin.
All right, you said fingers crossed. We're doing it. Hey,
yeah.
Where are your fingers? Okay. Arlena, thank you again. Quick check of the clock. We are now at L minus about 28 minutes to go before we launch GOES-T. Now, GOES stands for Geostationary Operational Environmental Satellites. Geostationary refers to where and how the satellite will orbit the Earth. So this might be a little difficult to understand unless you see it, right? So this is why we brought some props here today. Kevin, let's start off by just talking about how you determine a satellite's orbit.
So it's really determined by satellite's overall role, right? What is the job of that particular satellite? So in the case of polar orbiters, they typically will rotate along the poles, and their job is basically to image the entire planet as the planet rotates underneath it. So there is a time frame for which they can provide you a global image. And so again, in a low Earth orbit, that is why you'll see those particular satellites used.
But the geostationary orbit, it has to be in a fixed place, so in the sky at all times, right?
Correct. And actually, to achieve that, you have to be 22,000 miles above the planet, and as a result, so it can actually spin with the Earth as it continues to rotate. So relative to your position on Earth, you will always see this particular satellite in its place.
So that's why we say it will keep continuous watch over the Western Hemisphere with a second GOES satellite, right?
Absolutely. So between the two of them, they'll be able to cover this portion of the hemisphere. We're talking about from Western Africa all the way to New Zealand.
All right, and GOES-T will reach that geostationary orbit on March 12th. And now let's take a closer look at the satellite. GOES-T is the size of a small school bus and weighs over 6,000 pounds. It has a 5-panel solar array, which you see there. It's the one that's kind of swinging out. They'll produce more than 5,000 watts of energy, which is the same amount needed to power your home's central AC system. GOES-T has 6 advanced instruments that can analyze weather hazards and environmental conditions. The plan is for GOES-T to replace one of 2 GOES satellites already in orbit that together protect more than 1 billion people in the Western Hemisphere.
3, 2, 1. NOAA is about to launch a new satellite into orbit above the Earth. This satellite will be the 3rd in a fleet of NOAA's latest generation of geostationary operational environmental satellites, called GOES, the most advanced weather observing and environmental monitoring system in the Western Hemisphere. GOES satellites orbit 22,236 miles above the Earth's equator at speeds equal to Earth's rotation. This allows for continuous coverage of weather systems as they move throughout the atmosphere. The GOES satellite system keeps watch over more than half the globe, from the west coast of Africa to New Zealand, and from the Arctic Circle to the Antarctic Circle. Each satellite in the series provides high-resolution imagery in near real time to provide critical information for weather forecasts, severe weather prediction, lightning detection, and solar activity. The latest satellite is GOES-T, which will be renamed to GOES-18 when it reaches orbit. GOES-T will be the 3rd satellite in the series and is expected to replace the current GOES-17 satellite in the GOES West orbit. In this position, the satellite will continue GOES West's legacy of keeping watch over the Pacific Ocean, the western U.S., and the U.S. territories. It will provide complete satellite coverage for the weather systems that impact Hawaii and Alaska. It will provide critical data over the northeastern Pacific, where many of the weather systems affecting the continental U.S. originate. It will monitor and track tropical storms and hurricanes in the Pacific Ocean. It will help identify and track wildfires across the western U.S. It will assist in search and rescue efforts around the U.S. and its surrounding waters as part of NOAA's SARSAT system. And it will help monitor and track weather phenomena that impact the western U.S., like dust storms, monsoons, marine fog, atmospheric rivers, and more. The GOES series of satellites supports NOAA's mission to provide secure and timely access to global environmental data and information from satellites and other sources to promote and protect the nation's security, environment, economy, and quality of life.
GOES-T's instruments will gather data that can help in so many different ways, as you just saw. For more on that, let's hear from NASA's Leah Martin.
Thanks, Megan. I'm here with Pam Sullivan, NOAA GOES-R Program Manager. Pam, thanks for joining us today to give us some insight onto this mission.
Oh, it's great to be here. Thanks for having me.
So we've heard that there are 6 advanced instruments on board GOES-T. Can you tell us a little bit about them?
Sure. Let me tell you about our most revolutionary instrument, the Geostationary Lightning Mapper. It's actually the first time we've had this capability on orbit, and this instrument is watching the Earth, taking pictures 500 times a second to look at lightning. And because it is a new instrument, we're actually learning new and interesting things about lightning as a phenomena. For instance, we've seen that large wildfires can generate their own lightning. And the GLM has also shown us that lightning strikes can be really, really long. For instance, GLM recently measured a lightning strike that was more than 470 miles long, stretched from Texas over to Mississippi.
Wow. And so having that type of information, 500 images per second, that's almost like having maybe like a stop motion film. What can we do with that information once we have it?
Yeah, well, the important thing, of course, is what the forecasters can do with it. And they use the GLM data in conjunction with our advanced baseline imager data and some other data. But they look, when they're wanting to see if a storm is intensifying, they're looking at that lightning signature, and they're looking for what they call a lightning jump, when the amount of lightning strikes increase dramatically, because that indicates that the storm is likely to be becoming more severe and may spawn dangerous tornadoes.
Oh, wow. So we talked a little bit about the location, that this will become a satellite that observes the Western Hemisphere. What part, why is that location significant?
Yeah, specifically GOES-T is going to go into service as our GOES West spacecraft. So it'll be stationed over the equator, a little bit off of the west coast of the U.S. And as you know, most of the weather in the U.S. moves from west to east. So that western satellite is really important as giving us an upstream view of what's coming. So that's a big part of it. But the other thing, GOES-T will also see dangerous conditions that are particular in the west, like wildfires and smoke, dangerous dust storms, and also the phenomena of atmospheric rivers.
That's incredible. And so some of these instruments that are on board that are advanced, they're actually an advancement from current satellites that are in orbit now. Is that correct?
So the GOES-R series, compared to the previous generation, is much more advanced. The advanced baseline imager generates 60 times more imagery, and then the Lightning Mapper, as I said, is a brand new capability.
Thank you so much, Pam, for giving us some insight into this mission. We're excited to see the launch, and Megan, we're going to go back to you.
Perfect. Thank you so much, guys. One agency actually uses GOES satellite data more than anyone else, and that's the National Weather Service. So joining us now is Chrissy Hurley, who's a meteorologist there for the Nashville area. Hey.
Hello.
Good to have you.
Thank you for having me. So excited.
Yeah, and I know that your job is a warning coordination meteorologist. That means that you need to coordinate with people, public safety officials, if there's severe weather headed that way, right?
Yes, that's my main job is outreach with the public, TV meteorologists, and emergency managers and safety personnel.
We just heard Pam say that GOES satellite data, or GOES satellites look for things like atmospheric rivers. Can you talk to me about what that is?
Yeah, an atmospheric river is very similar to a river on land. It's taking moisture from a tropical region and transporting it in the sky to cooler, drier regions over land. And so this can be a sign for heavier precipitation or snowfall or rain, which could lead to flash flooding.
So it's a flooding event. There are many different kinds of flooding event, right?
Right, yes.
And so last year, I remember you and I were talking, there was a major flooding event. It was actually a deadly flooding event in August in that Middle Tennessee area.
Right. Waverly, Tennessee experienced a catastrophic flooding where we had over 20 inches of rain that occurred in McEwen, Tennessee, that less than 12 hours.
Wow.
And so we were able to use GOES satellite imagery to monitor the intensity of these storms and watch how they just trained over the same locations over and over and over, and able to alert emergency officials that rain wasn't going anywhere.
Wow, and the last time that Tennessee had an extreme flooding event like that was 2010, so that was a whole series ago.
Yes, big differences with GOES satellite imagery between 2010 and 2021. As a meteorologist and forecaster in National Weather Service office, data coming in much quicker, better resolution, and this is really going to help us, predict, forecast better, and save lives.
When we say much quicker, what does it mean? How often were we getting images in 2010 versus now?
In 2010, we were getting images every 15, 30 minutes. If you think your internet's slow now, it's like hitting the refresh button, right? Now we're getting them as quick as 30 to 60 seconds.
Wow.
And
Incredible.
So that is really making a huge difference for any operational forecaster.
Chrissy, thank you so much for joining us and giving us that insight, because that is really something to think about. Minutes versus seconds, and seconds really matter in severe weather events.
Absolutely.
Thank you, Chrissy. Now, GOES-T also has the latest technology in detecting and tracking wildfires. A few years ago, one wildfire tore through California at an estimated rate of 100 football fields a minute.
The 2020 Western U.S. wildfire season was historic, both for the record 59,000 wildfires that formed and the 10.1 million acres they scorched. But right on its heels was 2021, in which nearly 52,300 fires were recorded, with more than 7.8 million acres burned through December 24th of that year. Since launching in 2016, NOAA's most advanced geostationary satellites are improving fire weather forecasts, wildfire detection, and fire hazard tracking in near real time. With lives and property at stake, timely, high-quality data is critical for firefighting efforts on the ground. NOAA's GOES-17, operating in the GOES West orbit, has shown its mettle detecting and monitoring wildfires and the hazardous smoke they emit.
There's two instruments on the GOES series of satellites which are helpful for wildfire detection and monitoring. The first is the Advanced Baseline Imager, or the ABI. We're able to detect hotspots from the thermal signatures from the fires, and we're also able to detect the smoke and track the smoke with time in order to issue notifications and warnings to the public. The second instrument is called the Geostationary Lightning Mapper, or the GLM. The GLM is important because oftentimes lightning is the cause of the start of wildfires. And so forecasters can monitor the GLM to see where lightning has occurred to decide whether or not they think some lightning may have started a fire.
But a new satellite called GOES-T is poised to replace GOES-17 in the GOES West position. Once it reaches orbit, GOES-T will be renamed GOES-18, and it will provide the same sophisticated technology to track wildfires in the western U.S., as well as detect lightning that can ignite a wildfire in parched vegetation.
This current capability of GOES is the fact that we can do rapid scans, higher resolution with higher sensitivity, and include things for the first time like Lightning Mapper and the ABI instruments. I don't think we could imagine not having GOES capability. We absolutely need it.
The National Interagency Fire Center is the nation's support center for wildland firefighting.
GOES is an eye in the sky. It's giving us a hemispheric perspective with those 16 and 17 without having those two satellites up there constantly staring, constantly monitoring, constantly providing us with information. We really have just a big gap. We would lose a lot of our capability to understand the environment, to see the interaction of the fires with the atmosphere and see how the atmosphere is impacting the behavior of the fires. With those being able to look at the United States every 5 to 10 minutes, we're getting a much more real-time appreciation for how fires are behaving because of the ability of the GOES satellites to detect the heat from the fires.
Kevin, we were talking earlier, and you told me that oftentimes GOES satellites, even at 22,000 miles above the Earth's surface, they can sometimes detect fires before people on the ground even know that they're there.
Absolutely.
That's so impressive.
It's an amazing capability, absolutely. And we heard from our National Weather Service rep, I mean, right there, that's a great example of how it happens. National Weather Service meteorologists are able to view an area that's not populated, but they can see a heat signature and actually detect that fire. And we found out to the tune of 80% of the time, they're the first ones to actually call and let fire responders know that there's a fire that has just started or is ongoing.
So we know GOES satellites can help National Weather Service, fire officials, as we've said, but I didn't know this, that we use GOES satellite data every day.
Every single day. Anytime you open up your phone and you want to see the forecast and you're opening up an app, a weather app, that's exactly what you're doing. You're actually using GOES information. That GOES data is going directly into the models that inform you on what the conditions are going to be.
Fascinating. I can't. I had no idea. Here I am just looking, and you never think about where it came from. So thank you so much for telling us about that. We're now about 14 minutes away from launching GOES-T. Daryl and Mick, it's about time for that launch manager poll you talked about.
It sure is. And before we get to that poll, which is happening at L-13, so just about 50 seconds from now, we got an update from the launch weather officer. You can see on the bottom of your screen the weather briefing there, right there. They talked about the winds they're still pretty up, but the clouds have dissipated, so we are now at 90% go for launch, improving from that 80% earlier that you heard reported. But Mick, still got a 10% because we are watching those winds.
Yeah, as you can see in the forecast there, where Megan and Kevin are, the winds are still here on the ground, blowing pretty good. The team is continuing to monitor those. But yeah, I'm glad to hear that 90% go.
Winds for upper level, and they will remain green through 2218 Zulu, so significantly into the window. And then we get a later update should we need it.
Listening to
looks like we have very improved ground winds additionally, so we look great for weather. We've had a really good ground propellant load today, and very, very little activity on the range instrumentation. So with that, I would like to now conduct the GOES-T launch poll. NASA CE.
NASA CE is go.
Copy NASA CE, SMA.
SMA is go.
Copy SMA. SMD.
SMD is go.
Copy SMD. NASA MEM.
NASA MEM is go.
Copy NASA MEM. And LSP.
LSP is go.
Copy LSP. NLM copies. The NASA launch team is ready for the launch of GOES-T spacecraft.
And that was NASA Launch Manager Tim Dunn that you saw at the bottom of the screen there towards the weather briefing milestone. And so now we're good to go.
Yeah, Chuck, that was a very important. Sorry, Daryl. I'm thinking of that because
you heard
NASA.
Chuck.
I did hear Chuck.
Yeah.
NASA LSP. What I was going to say there is Tim paused at the end there because Chuck Duvall, NASA LSP, this will be his last mission as he just announced his retirement from NASA after 40 years. So this mission, Chuck, GOES-T. Thanks for everything you've done, and thanks for that go.
Been here a long time. Didn't he start as an intern?
He did.
Yeah.
He did.
That's a long career. Well, congratulations to him. And here we are with the rocket on the pad, ready to go. We're going to pick up this countdown. We're also going to have a special message from somebody you may know, a very popular and somewhat famous meteorologist. We're going to get to that in a second, but we'll send it back to Megan for now.
And GOES-T is one of many NASA science missions underway right now. Let's head back to Leah to learn more about that.
Hi, Megan. I'm here with Dr. Thomas Zurbuchen, NASA's Associate Administrator for the Science Missions Directorate, and this is a huge year for you and your team.
Absolutely. It's a year of science. Every year is a year of science, we say. Like we have an amazing number of launches ahead of us. In fact, Tropics, which is 3 launches. We have Maya, we have Emmet, we have JPSS. And you see the theme, it's all Earth science-related launches, some of them in partnership. We also have Psyche, yes, and then the first light of the James Webb Space Telescope, as well as many other, highlights this year alone.
Yes, and so many of the missions that you just mentioned are actually tied in to both weather and the environment. Why is that important for NASA and the work that we're doing? From the beginning,
NASA was about exploring the universe, but also exploring and understanding our own Earth and providing service for that. And the launch today, as well as many of the launches in the future, are precisely about that, understanding our changing planet, the system of systems. Everybody we love is right here. Our entire history is right here on that planet. So we want to understand and help protect it as we go forward.
And so the information that we get from these launches, how will we use that?
So the information we get from these launches, we use to get a better understanding in many areas. Of course, understanding, for example, Emmet, about the aerosols that are in the air. Where do they come from? We know they relate to precipitation in many areas, like how do they get transported globally? Maya, my daughter has asthma. It's about pollutants, learning from space, how to predict those and provide information for my daughter and the many others that suffer from asthma and so forth. That's precisely, each of them has an application like that, set of understandings that we want to bring to the table.
Complex science has a very simple application here on life on Earth, for life on Earth. So we also heard that the information that we're going to be capturing from these satellites is going to be available to the public as well.
Absolutely. Everything we do here in Earth Science and all over the science portfolio is information that is made public. We want scientists of all training levels, learners of all ages, to be able to look at this. But we also believe it's really important to trust the science. You should be able to look it up yourself and understand it. We think that's a really important part, and we've led that. We're actually moving from open data to open science. So we actually even make in the future the codes available that provide the actual predictions and the information that is there.
It's incredible using this information in conjunction with other information to give us the best picture possible. Dr. Zurbuchen, thank you so much for joining us today. We're looking forward to this launch. I'm sure that you are as well. And we really appreciate you being here.
Thanks so much, Leah. Absolutely.
Megan, we'll send it back to you.
Thank you both. And now taking us the rest of the way of the launch countdown is Daryl and Mick. Guys, take it away.
All right, thank you, Megan. L-7 minutes and 50 seconds until liftoff. Welcome back inside the Atlas Spaceflight Operations Center, the launch team right behind us, working this launch. And so far, things have looked really good and sounded good over the nets.
Yeah, everything sounded great. The team is continuing to finalize their work as we get ready to pick up the count at T-4 and sync up the L clock and the T clock. We're coming up on that launch conductor poll at L-7 minutes with Dylan Rice. So I'm looking forward to hearing all goes from the team to get GOES-T on its way.
You can look at the bottom of our screen. You can see the milestones as we count down to liftoff. We are coming up on polling, which is at L-7 minutes. In just a few seconds, we're going to pull up the poll on the right side of the screen and count it down.
L-7 minutes. Status check to proceed with terminal count. Atlas systems. Propulsion. Go. Hydraulics. Go. Pneumatics. Go. LO2.
Go.
Water. Go. Centaur systems. Propulsion. Go. Pneumatics. Go. LO2. Go. LH2. Go. ASGAS. Go. Electrical systems. Airborne.
Go.
Ground. Go. Facility. Go. RFFTS. Go. Flight control. Go. GCQ. Go. Operation support. Go. COM. Go. Umbilicals. Go. ECS. Go. Redline monitor. Go. Quality. Go. Ops safety manager. Go. ULA safety officer.
Go.
Vehicle system engineer. Go. Anomaly chief. Go. Range coordinator.
Clear to proceed.
Launch director.
You have permission to launch.
Proceeding with the count. ALC, verify T0 is set for 21:38 Zulu.
Verified.
ULA launch conductor Dylan Rice getting green across the board.
Yeah, that was great to see Dylan choreograph that poll, the culmination of several hours of work by this launch team, and then hearing Launch Director Tom Heater from United Launch Alliance giving that ready to proceed for launch today. So very excited and happy here to hear that as we get ready to pick up the count.
As we look outside at the rocket, we can see those blue skies. The clouds are moving a little bit, very slight amount of clouds. You don't see it here, but we're looking at blue skies. You can see some of them there. They're moving. That's representative of those winds. But as we know here in Florida, it's such a beautiful time of year in March. But Mick, 3 months from now, it'll be the start of hurricane season, which is a concern for Florida and everyone along the Atlantic seaboard and in the Gulf states.
Yeah, and I'll be very happy to have GOES-T up there in the west, as Kevin was saying, you know, all weather moving west to east. So getting GOES-T into proper position to follow those weather activities will be a great asset for everybody from a personnel safety standpoint.
And the public really relies on the public broadcasters who come out and give us that information about what's going on. And we have one of the more popular meteorologists that you may have heard of sent us a pre-launch message. Take a look at it now.
Hello, everyone. I'm meteorologist Jim Cantori from the Weather Channel Television Network, and I am so excited for the GOES-T launch. Meteorologists and weather anchors like me across the country depend on GOES data to bring you your daily weather forecast, but also to keep you and first responders safe during severe weather events. Accurate and timely forecasts are crucial, and that's not possible without satellites like this one. Godspeed, GOES-T.
3, 2, 1, mark.
And there you have the syncing up of the L clock to the left top
3:55.
and the T clock on the right-hand side. They are in sync, Mick, and that means we are starting up and really close to ready to go.
Yes, this is a very thrilling time for us, Daryl, as we get ready to perform a lot of activities here. The team's going to finish tanking and topping the vehicles, securing everything, getting things to flight pressure, getting the ordnance control unit armed, the flight termination system armed, getting the vehicle on internal power, which we heard a little while ago that the spacecraft GOES-T is configured and on internal power, ready for today's launch. So we'll be finalizing all these steps, the United Launch Alliance team that we talked about earlier, and they will get GOES-T ready for a liftoff at 4:38 p.m.
And there you can see from that shot of the pad out over the Atlantic Ocean, you see down towards the bottom of the rocket those two solid rocket motors. There's two on this side, two on the other. This is an Atlas 541 configuration, which we know is going to provide a lot of performance with those new GEM 63s.
Yeah, Daryl, the 541, as Tori Bruno, CEO of ULA, likes to refer to it as the Dominator. Those four solids will provide a lot of thrust as we get GOES-T off this morning. Using those new GEM 63s from Northrop Grumman will provide a little extra performance and get GOES-T on her way.
You can hear the team really picking up the chatter here as we get down to the final minutes for the launch of GOES-T on board an Atlas V rocket from right here at the Cape Canaveral Space Force Station.
Yeah, Daryl, we heard the team, they secured the Atlas tanks to flight pressures, secured that topping. So we see that the liquid oxygen on board that first stage is secure and ready to go. We should be hearing them at about 1:50 securing the Centaur tanks and getting that tank up to flight pressures, getting ready for launch.
Spacecraft is on internal, getting ready to listen for vehicle.
155.
Launch sequencer start.
150.
Securing Centaur LH2. Securing Centaur LO2.
So there we hear Daryl, vehicles on internal. The auto sequencer has taken over and started the count. And
Launch
Centaur
enabled.
LH2 and LOX
137.
sequences are done. Launch has been enabled by the launch conductor.
FCS armed.
The flight termination system has been armed. And the team is continuing to finalize all preps as the vehicle is getting ready for liftoff.
120.
FCS count started.
115.
Reduce ECS for launch.
Roger.
110. Vent valves locked.
And there we hear the vent valves locked, securing everything to secure that boil off. We should now be coming up on the last call for the range.
1 minute.
Rock, report range status.
Range green.
And there we have a green range, Daryl, so everything looks good this morning. Last but not least, we will bring everything to flight pressures and then hear that last status check from Dylan Rice.
And that'll be an exciting moment indeed as we look across the river there to a shot of the rocket. Just a few seconds left.
Stable at step 3.
And there we verified that all pressures are good, and we are stable at step 3, ready for liftoff this morning.
28.
Verify ECS reduced for launch.
Verified.
25.
Status check.
Go Atlas.
Go Centaur.
Go GOES-T.
And here we go. The final seconds now. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And liftoff of NOAA's GOES-T, our newest weather sentinel in the sky to help keep us safe here on the ground.
Daryl, let's listen in as we listen to United Launch Alliance Rob.
This look good.
Who's the flight mission commentator?
View has gone to closed loop control. The RD-180 is now throttling down as expected. Engine response looks good. We are now 33 seconds into flight. Atlas is 3 miles in altitude, 0.9 miles downrange distance.
Max Q, 48 seconds.
We have passed through Mach 1. Vehicle is now passing through max Q, maximum dynamic pressure.
Throttle back those RD-180s.
Now 55 seconds into flight. Atlas is 7 miles in altitude, 4 miles downrange distance, traveling at 1,900 miles per hour. RD-180 is now throttling back up.
Backed off the throttle to reduce
Now
the
at
stress
75
on the
seconds
rocket.
into flight, Atlas is 13 miles in altitude, 10 miles downrange distance, traveling at 2,700 miles per hour. Now at 90 seconds into flight, ULA's Atlas V rocket weighs now just 1/2 of what it did at launch, burning propellant at a rate of more than 2,600 pounds per second.
In 10 seconds, those solid rocket motors on the side will cut off. Beautiful shot from space.
SRBs have burned out as expected, and we see a good SRB jettison.
Clear shot of those
Vehicle's now
SRBs.
executing closed-loop steering.
Here in a few seconds, they're going to throttle back up.
Vehicle performance looks good at this time. Now 135 seconds into flight. The RD-180 has throttled down slightly. Vehicle performance continues to look good at this time. Tank pressures are stable, and Atlas booster battery voltages remain in their expected ranges. Now the upper stage is preparing for its use. Centaur reaction control system is now pressurizing to flight levels.
Now they'll jettison the payload fairing, which protects GOES-T at 3 minutes and 30 seconds.
We have just over 1 minute until BECO. We're now seeing the RD-180 throttle limiting to maintain a 2.5 G acceleration limit. Standing by for payload fairing jettison. And we've seen a successful payload fairing jettison.
Good shot of those fairings.
RD-180 is throttled back up now. And the vehicle has reached a 4.6 G acceleration limit and will maintain this level through BECO.
And you're looking at animation now.
We've seen that the Centaur has begun its boost phase chill down sequence.
Booster about to cut off.
And BECO, booster engine cutoff. Standing by for stage separation and a successful stage separation event. We've seen pre-start on the RL-10. And mess one, we have ignition for the first burn. This first burn of ULA's Centaur upper stage will place the GOES-T spacecraft into a parking orbit around the Earth. This burn will last just over 7 minutes.
What a shot there, huh, Mick?
Yeah, that was great, Daryl, to see all that and listen to Rob Kesselman call that flight. The first stage performed very well this afternoon, and everything's looking good. Those GEMS
Activity on the reaction control system as it begins its periodic firings to maintain thermal control conditioning.
Yeah, those GEM 63s performed well, solid rocket boosters, and RD-180 performance well. What I really liked was when we saw the payload fairing come off. That was a great shot from the camera. Saw the payload fairing come off, and then most people probably noticed that little half cylindrical come off after payload fairings. Yeah. That was what we call the Centaur forward load reaction deck. Because the fairing, the 5-meter fairing, encompasses both Centaur
As expected.
and the GOES-T satellite, there's a load ring that's inside the fairing around Centaur to help keep that 5-meter fairing from flexing. So that's what you saw when you came off there.
I was wondering about
And
that.
the engine response remains nominal.
And so
word from the trajectory and performance group that booster performance was as expected for the booster phase of flight.
All right, we're going to keep an eye on this burn and listen in. But in the meantime, we'll send it back to Megan out at the host desk.
If you're just joining us, welcome live to Kennedy Space Center in Florida, where we just saw GOES-T launch from just behind us at Cape Canaveral Space Force Station. And guess what, everyone? I just found out that this was Kevin's first launch.
It was.
How was it?
It was super exciting. Almost a proud moment as an American, 20-year Air Force vet, and to be able to see this was awesome. Absolutely awesome.
Yeah, I'm so glad to be here. It was very fun to watch you react. Like you were like you were like a kid. Like, I have to take this. Oh wow, it was great.
Absolutely.
It was great. So what's next for this mission?
Well, the wonderful thing about this, now that we've had a successful launch, we have about 12 days before it actually reaches geostationary orbit. So at that point, that's when we'll start our checkout phase. We'll be looking for the data to come down from the spacecraft to make sure everything checks out, that the images are correct, all that kind of stuff has to work its way through.
And GOES is NOAA's latest weather satellite, as we've said. We've been launching GOES satellites together for nearly 50 years. I mean, there's been so many advancements made in between those times.
There have. And, I like to remind people that, this particular satellite in the series is really an evolutionary step, much like cell phones. Or when we talk about, hey, do you remember when we used to use landlines and rotary phones? Well, think about the leap we've taken from then to the cell phones and the capabilities that we have, much like that with our satellites.
Yeah, I know. I feel safer knowing that GOES satellites are up there. And now I'd like to bring in NASA's Leah Martin, who got to watch the launch with our agency's Deputy Administrator. Leah.
Hi, Megan. Like you said, I am here with Pam Milroy, NASA's Deputy Administrator. And what did you think of that launch? So exciting.
It was exciting. And it was, I don't know, I always just feel this electricity when a launch goes up. You're like, wow, people can do this. This is just the power and the majesty of it as you see it lifting into the heavens. It's always exciting.
And, hours and hours and months of work that go into it. Absolutely. So, NASA's vision is to expand knowledge for the benefit of people here on Earth. That's the heart behind everything that we do. How does this mission fit into that?
This mission is a great example of our mission in a lot of different ways. I think one of the most powerful things that we do at NASA is we partner with others to maximize the benefit of the things that we do. So this mission to launch the GOES-T satellite will enable us to have cutting edge capabilities that are looking down on the Western Hemisphere, the western part of the United States, to ensure that the data that goes into the NOAA models around weather are optimized, they're up to date, they will affect people's lives, whether it's farmers or protecting from wildfires. But what's interesting is we're also going to take that data because we have Earth scientists who are modeling our Earth as a system and climate far out into the future. This isn't an operational weather, which is what NOAA's mission is. They do it very well. But we take this data and we also use it for the benefit of science. So it's a really synergistic partnership.
And you just mentioned climate change and monitoring the changes because that is a priority for NASA.
It is. It's one of our top priorities. We are already doing a significant amount in this area. Earth science and looking at our own Earth has always been an important part of our science mission. Interestingly, we also study other planets in the solar system, such as Mars, which we believe was once wet and had more of an atmosphere. And so the question is, how did it get the way that it did? And how do we make sure that does not happen to our planet? So it's a critical part of our mission.
Well, we're hoping that the information that we get today can feed into the future missions of tomorrow. If nothing else, we'll certainly know the weather. Pam, thank you so much for joining us today. We really appreciate it, and we hope you enjoyed the live.
Exciting day.
Megan, back to you.
Thank you, Leah and Pam. And Kevin, GOES-T doesn't just forecast the weather. We've talked about this a little bit. We've talked about how it monitors the atmosphere for fog, dust storms, and smoke, and especially for wildfires. But what about like smoke and ash for volcanic eruptions?
Yeah, absolutely. This past year has been kind of a revelation in our capabilities to view volcanic eruptions. In particular, probably the most spectacular example will be the Tongan. But what we also have is another example in the Caribbean where you can see not only the amount of ash that goes up, but the area that it covers. And as a result of that particular hazard becomes an aviation hazard in particular.
Yeah, you can see all the smoke there. Weirdly enough, 2 years ago, I was traveling in the Philippines, and there was a volcanic eruption there, and we had to ground hundreds of flights because of it. So really, GOES helps decide whether or not it's safe to fly.
They do. Again, NOAA's partnered with the FAA, and they provide them with those volcanic ash, both forecasts and projections for where that ash could go.
All right, we're now approaching another milestone in the ascent. Daryl and Mick, back to you.
Thank you very much, Megan. And we continue to burn, continue to get good numbers as we monitor the flight of the Centaur and GOES-T.
Yeah, things are looking really great on this flight, and coming up on MECO 1 of that Centaur engine as Centaur continues to perform nominally. We've heard pressures and everything look great.
PU system has gone open loop.
Here in about 10 seconds, we'll have the
Standing by for the end of the burn. And we have MECO. Main engine has cut off.
There you go. That completes that first burn. And so now we go into about an 11-minute coast phase, Mick.
At this time, the GOES-T spacecraft and ULA Centaur upper stage are in an unpowered coast phase that will last approximately 11 minutes. The coast allows the vehicle to move to optimal orbital position in the orbit prior to beginning the second main engine burn.
And what you're looking at is animation that is tied directly to the telemetry we are receiving from the rocket.
Yeah, the team is using all the vehicle telemetry to look at and
the
power
reaction
this.
Control system is operating at the 100% settling mode at this time.
Power this animation that we're seeing, which is really good. And as we heard Rob Kesselman say a minute ago, this approximate 10-minute coast, we're in this park orbit around Earth right now as we coast around to get into the proper trajectory we want to be for that second burn, which will then send us on our way towards that geostationary spot we want to be. It'll be a longer burn, and then we've got, Daryl, that long 3-hour coast that we're going to wait around for.
3 hours, folks, between the points on the bottom of your milestone list, between MECO 2 and MES 3. That's 3 hours. It's short there on your screen, but it's a long one. As you're looking at the animation, we are in orbital darkness. The sun is blocked out, and so the animation is reflecting that at this time, so we can't see the Earth behind it. They give it that kind of accuracy in terms of its look. So the spacecraft is in total darkness, but when it comes out and those solar rays unfurl, it'll have some power. All right, we're going to send it back to Megan for now, and while we coast, but we'll be back for that second burn.
Thank you both. Now, GOES-T will warn us about weather here on Earth, but also space weather. But what is that, and how does it impact us here on the ground? Take a look.
So the sun, looking here from the ground, seems very constant and quiet. But actually, when we look at it from space, we can see it's quite turbulent and active. Space weather is activity on the sun and in a near-Earth space that can affect our technological infrastructure and society. The sun is constantly spewing out a stream of particles called the solar wind that goes out into the solar system. And it affects us here near Earth, where we're protected by a magnetic field. The interaction between the solar wind and the magnetic field can cause space weather. The Carrington event is the largest storm we've seen in recorded history when we're looking at space weather. But every solar cycle, which repeats about every 11 years, one estimate estimates that there's a 10% chance of getting a large storm like the Carrington event that could impact us here on Earth. But we see solar storms almost all the time. And these storms have an effect on our technological infrastructure. Solar storms can cause activity in Earth's atmosphere and magnetosphere that can damage electrical power grids that power our communities, interrupt radio and satellite communications, and can cause our GPS navigation to fail. NOAA is working with its international partners to ensure that we have different vantage points where we can observe space weather. Our space weather observing infrastructure from space includes the NOAA Discover satellite and the NASA ACE satellite that are stationed upstream of Earth to give us a first buoy measurement of the solar wind. It also includes the ESA NASA SOHO satellite and the NASA stereo satellite that image the sun and also make coronagraph measurements of the outer atmosphere of the sun, the corona, that can tell us when large explosions happen off the sun. We also observe the sun and the Earth's magnetic field from the geostationary location with NOAA's GOES. So the way we use the space weather information from satellites and from the ground is to be able to make forecasts and predictions, just like we do with hurricanes and terrestrial weather. We observe the sun and look for activity and see how it develops, and see if it's going to culminate into a large explosion that can affect us here on Earth. NOAA is working with its international partners to expand our observing capability. We're committed to observing along the Sun-Earth line. So we're going to do the imaging of the sun and the upstream buoy measurements of the solar wind along the Sun-Earth axis. The more we understand about the sun, the more we can prepare for it and become, just like we are a weather-ready nation, become a space weather-ready nation. And as we look forward to humans exploring out into the solar system and advancing our space commerce activities, space weather becomes more and more important.
GOES-T is one of many satellite programs operating right now. Leah is standing by with someone you know very well, Kevin.
Dr. Spinrad, our administrator.
Yeah, NOAA's administrator. All right, take it away, guys.
Hi, Dr. Spinrad. Thank you so much for joining us today for the GOES-T launch. We really appreciate it. So this launch is actually not the only NASA NOAA launch that we have a collaborative effort with this year. We have another one coming up as well.
Yeah, that's right. Thanks for having me. And in fact, this next launch will be a polar orbiter, which is fundamentally different from what we launched here today. So we call it a geostationary satellite. As the name implies, it's Earth synchronous. It actually follows around and looks at one spot on the Earth, if you will. And then the JPSS launch is we call it a sun synchronous. So it actually stays at a certain sun illumination and does orbits around the pole many times to give us a different look at the Earth as it's spinning on its axis. And you take the JPSS satellite data and the geostationary data together, and it's like taking pictures at multiple angles to get a much better idea of what's happening on the planet.
So that's information that we can use independently, but we can also use them together just to get a better picture of what's happening.
Absolutely. Think of it in terms of being able to forecast weather, say, 2 days ahead versus a week ahead. And if you've got multiple views of the planet, you can start getting a much better handle on when hurricanes are forming, where they're forming, how intense they are, or things like atmospheric rivers forming way out in the middle of the Pacific. When will it arrive in the Pacific Northwest? So having these multiple ways of looking at the Earth gives us a lot more and a lot better information for these critical forecasts to save lives, protect property, and basically protect our American public from these natural phenomena.
Now, and the system that is currently on orbit is set, I believe, to go through the 2030s. What comes after this?
So we've called this series the GOES-R, the Geostationary Operational Environmental Satellite R series. There are 4 of them. We've launched the 3 here today. And after this series, we're looking at what we call GeoExo, extended observation. So what does the next generation of geostationary satellites look like? What's the newest technology we can put on there? Are there different phenomena that we can look at in the Earth system, but also out at the sun, for example, to understand what's happening with solar storms that impact us here on Earth as well.
So really it's science for today while we're facing forward to science for tomorrow.
It absolutely is. You think about how many years it takes to build a satellite like the GOES series, and you want to make sure that you're putting the state-of-the-art science and technology in the satellite that may not launch for 5-10 years. So what do we think the scientific capabilities will be in 5 or 10 years, and let's start working in the laboratory now to build those new sensors and those new operating systems.
It's incredible to think that, you know, in just another decade or more that we could be here talking about a completely different system. Thank you so much for joining us today. We really appreciate it. Megan?
Really interesting to hear about everything that's happening that we can really all learn from. It's been about 21 minutes since launch. Dale or Mick, we're coming up on that second burn now.
Yeah, we sure are. And thank you, Megan. Back inside the Atlas Spaceflight Operations Center, Mick Woltman here with us, LSP engineer. We're heading towards orbital sunrise. We've been in a coast phase right now, heading over Africa, West Africa, across the southern coast there. And we've got a burn coming up in just about a minute.
Yeah, this second burn is very important as it'll get us out of this park orbit around Earth and get us on our way towards that geostationary orbit we want to head for GOES-T to allow them to do their science and protect us with all those instruments they've got for weather realization.
You're looking at animation now tied to real-time telemetry, the Centaur on the left part and GOES-T on the right part, as it chases the sun. Mick, chasing orbital sunrise here in just a few seconds, and ULA kind of basically simulating that with a more lighted landscape.
And there we hear pre-start on the RL-10 coming up from Rob Kesselman. Data showing that RL-10 is getting ready to ignite for this second burn.
LOX pre-start on the RL-10. We have ignition, MES 2.
All right, main engine start number 2. We have advanced across the bottom of your screen where we have all the milestones listed. We're going to burn for about 6 minutes. As you mentioned, Mick, this is really hitting the gas
PU
and
has
getting
gone to
out
closed loop
deeper into
control.
space.
Yeah, absolutely. This is going to be the burn where we get GOES-T headed out where it needs to be, and then we'll coast for that 3-hour
Vehicle
period
body rates are stable
to get
during
where
this
we
initial
need
part of the
to
burn.
go, and then get ready for separation. So still a lot to go from here, but this is a very important burn for the mission.
Going deeper into space, approximately 22,000 miles away from the surface of the Earth. Mick, I want to take you back. Of course, we know that this satellite here can have ability to map lightning. It's got high technology on there that's very valuable. But also, when it was on the ground,
10 thrust chamber
it could have
pressure.
been it could have been suspect, rather, I should say, susceptible. Sorry, susceptible to lightning when it was on the ground. But Launch Services Program developed some technology to help protect it, and I was fortunate to go out to the pad. This is something that you do a lot, go out there to the launch pad, but I was invited to go out with one of LSP's young engineers to share and install this equipment that helps protect against delays. Let's check it out.
Hey, Alex.
Hey, Daryl.
Good to see you.
Good to see you too.
Hey, thanks for having me out. So this is it.
This is it. This is the PLI.
The NASA Portable Lightning Instrumentation. I see it right here. You're going to take it up there all the way where the top of the rocket is?
Yeah, right around where the payload fairing is, level 5.
All right.
That's where we're going.
Well, you need a hand?
Yeah, come help us.
Now that we're inside the VIF and we're about 13 stories up, tell me a little bit about this box. You've got some, looks like some sensors here.
That's right. So we got the current probe, which is over near the rocket, and we have 3 more sensors over here. This one is an electric field sensor. This one up here is a magnetic field sensor. And this little one over here, that's a GPS antenna. That's how we make sure our data stays synchronized in time, so that we can correlate that data to all the other lightning detection networks in the area.
So what happens if there's a lightning strike somewhere nearby? What does this do?
So if it's close enough to cause any interference in this area, these field sensors will pick it up first. And they'll cause the entire system to take a snapshot of that data and record it.
And how is that helpful?
We'll know what the peak of it was, we'll know how long the transient lasted, we'll be able to calculate how much energy traveled through there, we'll have a lot more information to work on.
Small box, big rocket, but it's got a big role in the whole scheme of things.
It's got a big job, that's for sure.
So we can see those lightning towers out there. And NOAA tells me that that protects the rocket when the lightning strikes. So why do we need the PLI?
Yeah, so this system over here, we call that the lightning protection system. That's designed to protect it from a direct lightning strike. That means the lightning is attaching directly to the rocket, and we're concerned about, a lightning strike out there in the ocean, maybe just a mile away. And the energy in a lightning strike is so intense, it creates these very powerful magnetic and electric fields. And those are the things we're concerned about, because that magnetic field can come through and couple into the umbilical cable. It's a huge loop. It makes a big old loop, and that's the current we're looking for with the PLI.
Has the PLI ever prevented a long launch delay for a previous mission?
Mars 2020 was where the data from the PLI gave the spacecraft team the confidence to go ahead and launch.
So there was a lightning strike around the Mars Perseverance rocket.
That's right.
And you saw it?
And we gathered that data, yep.
And it launched on time.
It did. And it's up there now.
That's right, on Mars.
That's right.
Well, that was a lot of fun to go out there, and Alex, of course, was great to have me out there at the pad. But this technology, really helpful when you have a lightning strike. It was connected up inside the VIF when GOES was inside.
Yeah, Alex and the team have done a great job with that. They've been studying this for years, and they came up with this PLI, and working with our commercial partners, they've been able to install it, like you said, on the VIF for the Atlas V mission. And as Alex mentioned, we actually used it during Mars 2020 to help us verify some information, so we didn't have to go back and retest anything, and it actually saved the launch from delaying. So, the hardware is great for what we have involved in it.
Especially important for a planetary window like Mars, where you only had so much time to launch to make it to the planet. But we are in the midst of a 6-minute burn. We're about to wrap that burn up in just a few seconds.
You have gone to open loop control.
You're looking at animation of the Centaur upper stage. You're also looking at GOES-T spacecraft as represented by animation. Just a few seconds left in this burn.
And we have MECO 2, second stage main engine cutoff.
And there you go. We have completed the second burn.
RCS is now operating at 100% settling level.
Really got away from the Earth, and now we're cruising pretty good speed away towards that stationary point where they want to get that geostationary orbit.
Yeah, this is the moment we've been talking about a little bit, right? This is that 3-hour coast that we're going to have Centaur and GOES-T do their thing, head out towards that geostationary where they want to get to, so we can have that third burn of the Centaur. And what we'll see on that third burn, Daryl, is that after that 3-hour coast, Centaur will go through its process again of pre-chilling the engine, doing some things to get ready for that.
Centaur is now entering an extended duration coast phase. This coast phase will last approximately 180 minutes, where we'll have a final third burn prior to spacecraft separation.
Yeah, so we've now flipped the bottom of our progress bar to a countdown clock to show you and represent that 3 hours. When we return, we should be out of Africa and near the coast of Australia. So we're going to do some cruising.
Yes, we are. This is, like I said, longest part of the mission, but very much needed to get GOES-T where she needs to be.
All right. For now, that's going to wrap up our coverage for this initial part of the mission. We will be here throughout, listening to the loops, monitoring the launch team. Mick's not going anywhere either. Nope. He's going to lock it down, and of course, we'll give you all the updates as we go along, and then rejoin you finally after the 3 hours. But for now, we'll send it back to Megan and Kevin.
Yeah, as I just mentioned, GOES-T will now coast for about 3 hours before spacecraft separation. We will stay on air for this coast phase to bring you those live animations you've been watching, as well as commentary from Daryl and Mick. You can expect those hits at the top of every hour at 6 and 7 p.m. Eastern Time. In the meantime, we have some fantastic art to show you from kids around the world as part of NASA's Space Place Art Challenge, where every month we invite kids to draw something space-related. And in honor of GOES-T's launch today, we asked kids to draw GOES-T observing the weather where they live. And then at 8 p.m. Eastern, Kevin and I will be back to cover the rest of the mission, so set your alarms, and we'll see you back here soon.
See you then.
You forgot.
I did.